Dear students, welcome to this NPTEL course on spectroscopic techniques for pharmaceutical and biopharmaceutical industry. I am Shashank Deep, a professor in Department of Chemistry of Indian Institute of Technology, Delhi. I have opportunity to teach physical chemistry courses on spectroscopy, thermodynamics and kinetics. I have also taught biophysical chemistry and taken biochemistry practicals. Our research area is based on application of spectroscopy and microscopy to look at different processes associated with proteins. In this course, 3 teaching assistants will be helping me: Komal Singh Khatri, who has done PhD under my guidance, Shilpa Sharma and Vishakha Goswami, who are doing PhD currently under me. First, we will start with introduction to spectroscopy. We will talk about interaction of electromagnetic radiations with different materials, and then we will go to your different kind of spectroscopy: vibrational spectroscopy, rotational spectroscopy, Raman spectroscopy, electronic spectroscopy. Then we will go to fluorescence. We will study NMR spectroscopy and mass spectroscopy. We will also discuss microscopy, basics of microscopy, and then we will one by one we will discuss fluorescence microscopy, electron microscopy and scanning microscopy. We will also discuss surface plasmon resonance spectroscopy and flame photometry. The requisite for this course is you must have done BSc in chemistry. You should have knowledge of basics of quantum chemistry. The books which I am going to refer is your one basic book, which is Engineering Chemistry by P.B. Joshi and myself. So, this is a book which is co-authored by me, and this has come from Oxford University Press. Good thing about that is it gives you about basics of physical chemistry and other chemistry, and also it discuss the applied part of the chemistry. So, utilization of chemistry in different kind of applications. Then we will refer to books on quantum, spectroscopy and microscopy. The book which we are going to refer quite often is Modern Spectroscopy by Hollas, and this is from Wiley publication. Absolutely Small by Michael D. Fair. It is a very nice book to read, and I will be referring to this quite often. And then Fundamentals of Molecular Spectroscopy by Banwell and McCash. These are all about physical part of spectroscopy. Then I will also go to Organic Spectroscopy, and the book which I am going to refer is book by William Camp from Palgrave Publications. And for microscopy, I will be referring to Understanding Light Microscopy by Jeremy Sanderson, which is from Wiley Publications. We will also look at some specialized book on spectroscopy. For example, for NMR spectroscopy, particularly when we are discussing principles of NMR spectroscopy, I will be referring to Understanding NMR Spectroscopy by James Keeler. This is also from Wiley Publications. And then for fluorescence, I will be referring to Principle of Fluorescence Spectroscopy by Lakovich, which is from Springer. For application part, I will be going to different literatures, and I will be taking one paper out of it, and I will discuss you. This is particularly important when I am discussing applications in different areas which utilizes spectroscopic techniques. We have taken lot of figures, animations from web books. I have tried to acknowledge all of them. If there are omissions, then please let us know. So, what is spectroscopy? Spectroscopy is set of methods where interaction of electromagnetic radiation with chemical molecules is measured to obtain characteristics, properties and quantity. So, there are two parts of this. One is your interaction of electromagnetic radiation with chemical molecules, and here we will look at how does electromagnetic radiation interact and what is the principle behind their interactions. And then the second part is your characteristics, properties and quantity, that is your application part. So, in applications we will discuss how to use spectroscopy to obtain characteristics, properties and quantity of different chemical molecules or biomolecules. So, this course had two very important parts, theory and applications, theory and application. So, in theory part I will be discussing physical chemistry of spectroscopy. In application part I will be going to organic molecules, biomolecules and medicines to show you how spectroscopy can be applied. So, this is a combination of both physical chemistry part of spectroscopy, organic chemistry part of spectroscopy and then spectroscopy application in medicine, spectroscopy application in medicine. So, in theory part we will discuss three different kind of questions: what happens, the second is why, and third is how. I will go one by one and discuss what I mean by these three type of questions and how a spectroscopy can help in knowing the answer of these questions, knowing the answers of this question. Now, second part application, again we will discuss three different kind of question: how, which and can, how, which and can. So, for example, if we are discussing what, then we will discuss what happens when electromagnetic radiation interacts with matter. So, in this course we will be going to discuss what happens when electromagnetic radiation interacts with matter, what happens when microwave radiation or IR radiation interacts with the molecule, what is the difference in the event which takes place when a molecule interacts with microwave radiation or a molecule interacts with IR radiation. We are going to discuss what is the principle of NMR spectroscopy, what is the principle of IR spectroscopy, what is the principle of Raman spectroscopy and what is the principle of fluorescence spectroscopy. So, we will go one by one to different kind of spectroscopy and we will discuss the principle behind it. Then we are going to ask some questions like this: what are the factors which can affect resolution of a spectrum? So, resolution of a spectrum or broadness of a spectrum depends on how many factors. What are the factors which can affect intensity of a spectrum and what are the factors which affect frequency of transitions, what are the factors which affect different kind of spectroscopy, different kind of spectroscopy. So, we will discuss the factors which affect resolution, factors which affect intensity, factors which affect the frequency of transition and factors which affect whether a particular molecule is IR active or not, microwave active or not. These are the things which we are going to discuss in this course. We will also discuss what happens when food is cooked in a microwave oven, what are the appliances which are based on IR technology, what are the appliances which are based on NMR technology, what are the appliances which is based on X-ray spectroscopy. We will also discuss what are the products in the reaction, what are the impurities in the sample, what are the concentration of particular analyte in a sample. So, this kind of question we are going to ask. Then come to second part of the question, why. So, in this course we are going to discuss why cherries are red, why blueberries are blue, why a leaf is green. So, this kind of question we are going to discuss. Our world is colorful and different objects have different color. We are going to discuss why a particular object has that particular color. Then we are going to discuss why CO2 is a greenhouse gas. So, our atmosphere has a different kind of gases and some are in greater amount comparison to CO2. Still CO2 is known as greenhouse gas. So, what is reason for that? We are going to discuss why some stars are red and some stars are blue. So, when you look in the sky in the night time, you can see some stars looks like red, some stars looks like blue and some are in between them. We are going to discuss why their color is different, If you look at sky during different times of the day, for example, during the daytime the sky will look blue, while when sun is setting the sky will look red. So, we will discuss why sky looks blue or red during different part of the day. Now, we are also going, so this is about why part. Now, let us come to the next question, how. So, first question we will ask that how does a human being see a color? Why to us a particular color looks like that color? So, why apple look red or why blueberries looks blue? So, we are going to ask this question that how does we see a color. We will also ask how does a bee discriminate foliage. How does a bee discriminate foliage? We are going to discuss how does viper detect warm blooded prey. These are the questions which are related to spectroscopy, and so we will discuss that how does a particular animal discriminate between two objects. We are going to discuss how to determine the structure of molecule, and this is a very big field. Not only molecule, we are going to even discuss how to determine the secondary structure of protein, how to determine tertiary structure. So, for example, how to determine whether a protein is alpha helical protein or beta sheet protein. Similarly, we are going to discuss whether a protein is folded or unfolded. Can we use a spectroscopy to know the conformation of protein? We are also going to discuss how to determine the structure of DNA molecule. Not only about a structure, we are also going to discuss about concentration. How to determine concentration of a simple molecule, how to determine the concentration of protein in a particular sample, how to determine the concentration of DNA or RNA in a particular sample, and how to determine the amount of viable cells. So, when cells are dying, how can we know how many cells have died and how many are viable? Then we are going to discuss how to measure the blood glucose level in the body. Since this is related, this is very important. If you consider a diabetic patient, we need to measure his blood glucose level. So, we are going to see how we can measure the blood glucose level in the body. we want to know how to measure the amount of iron in our body. Then if you look at the atmosphere and try to measure the amount of pollutants, how we are going to measure the amount of pollutants in the atmosphere, for example, CO2 in the atmosphere. So, we are going to discuss that. We are going to discuss how to measure the amount of mercury in the water or amount of any toxic material in the water. So, this is related to your pollution. Then there are different set of questions, for example, how to distinguish between natural rubber and butyl rubber. So, this question is how to distinguish. So, how to distinguish between polymers, for example, polyacrylonitrile and polyethylene terephthalate. How to distinguish between polyethylene and polystyrene, these are two different polymers, look same. So, how we will distinguish between these two polymers, and then we are going to discuss the difference between a synthetic and natural rubber. We can also ask question based on the distinction between two different isomers. For example, we will ask questions such as how to distinguish between cis and trans isomer of 3-hexene, how to distinguish between two enantiomers of a molecule, and how to distinguish between two isomers of alkanes, how to distinguish between two isomers. So, what are the ways to distinguish between two different conformers, two different isomers, two different enantiomers and two different tautomers. So, we are going to discuss that. We are also going to discuss how to measure bond lengths and bond angles of a molecule. We are going to discuss how to measure different physical properties, different physical parameters of a molecule, for example, bond lengths and bond angles. We are going to discuss how to measure dipole moments, bond dissociation energy, and how to measure bond energy and bond stiffness. So, these are the few of the physical parameters we are going to see how to measure them. For a reaction, we will discuss how to measure equilibrium constant of free energy. We can also see that we can utilize spectroscopy to measure enthalpy and entropy of a reaction. We can also measure rate of reaction and order of reaction with the help of spectroscopy. And if you measure rate of reaction with respect to temperature, we can also measure your activation energy. We can measure rate constant of the reaction and activation energy of a reaction. Now, this is about how we will do that. Now, next question is which. So, we are going to ask which technique is best to know the functional group in a compound. So, every technique, every spectroscopy, for example, IR spectroscopy is very often utilized to know the functional group in a compound, and microwave or your rotational spectroscopy is used for different purpose. So, which technique is best to know the functional group in a compound, which technique or combination of techniques is best to know the structure of a compound, which technique is best to know the secondary structure of a protein, and which technique is best to know the tertiary structure of protein. So, every spectroscopic technique has their own advantages and their own limitations, and after doing this course you will be able to know what is the limitations associated with particular kind of spectroscopy, or what is the strength associated with particular kind of spectroscopy, and that will help you to decide which spectroscopy will be suitable for particular kind of application. We are going to discuss which techniques is suitable to distinguish between two compounds with different functional group, which technique will be best to distinguish between two geometrical isomers, which technique is best to distinguish between two conformational isomers, and which technique is best to difference between two tautomers. So, this structural features can be distinguished between two different molecules using one of the spectroscopic technique, and we are going to discuss which spectroscopic technique is going to best for particular applications, So, we just discussed that spectroscopy can be used to calculate different physical parameters, and so we are going to ask, or we are going to see that which technique will be best suited to calculate dipole moment, which technique will be best suited to calculate bond length and bond angles of a particular molecule, which technique is best for calculating the bond dissociation energy, and which technique is best to differentiate between two tautomers. So, spectroscopy is utilized by different industry apart from the academia people from academia. So, spectroscopy is used in chemical industry, it is also used in pharmaceutical, it has uses in medical and health, it is quite often used in agriculture and environment, and it is also used in forensic science and astronomy. So, we will be discussing about how spectroscopy is going to be used in the different industry, where these industries uses the spectroscopy, in which kind of application they utilize spectroscopy. For example, if you take the case of chemical industry, they uses spectroscopy in identification of organic compounds. They also utilizes spectroscopy in detection and identification of when small amounts of impurities in the synthesized organic compounds. They also need quantitative determination of such impurities. So, they often use a spectroscopy to determine the amount of impurity. They also study reaction mechanism and rate of reaction. Kinetics is very important, and so spectroscopy can be used to study reaction mechanism and speed, and even in detection of intermediates. Spectroscopy is quite often used for a study of polymerization and copolymerization, which is related to the plastic industry. Spectroscopy is also used in food industry. It can tell you about every component of food. So, if you have a food sample, there are several different components. You can look at each of the component, and thus you can detect if the component, the food is mixed with some unwanted material, and so you can detect the kind of fraud if it has been done with that food sample. Using spectroscopy, we can look at all the raw materials and ingredient used in food production, and thus we can use that information to detect any modification in food stuff. Again, spectroscopy is utilized quite extensively in pharmaceutical industry, and some of the applications are basic drug research and structural elucidation. So, if you want to make a drug, then you need to know the structure of drug after formation, and thus spectroscopy is essential tool in pharmaceutical industry. Not only in the synthesizing and characterizing the drug, spectroscopy is also used in formulation development and validation. The another area where spectroscopy is quite often used in pharmaceutical industry is quality control processes for incoming and outgoing materials, and finally, all the drugs are packaged, and so packaging is also tested in pharmaceutical industry using spectroscopy. Apart from that, spectroscopy is quite often used in medical and health industry. For example, if you want to monitor blood glucose level, spectroscopy can be an important tool. You can monitor iron level of a person and tell whether he has anemia or not. Spectroscopy is utilized in monitoring of growth of cancer cell lines. It is also utilized to monitor death of cell lines. You can monitor up regulation and down regulation of specific metabolites, which will tell you that you have symptoms of a particular disease or not. CT scan based on X-rays and MRI based on nuclear resonance spectroscopy is widely used for detection of tumors, and histology and immunohistochemistry are microscopic based techniques. So, here is your different spectroscopy and application. For example, nuclear transition is used in SPECT and PET imaging. Your fluorescence is often used for analyte discrimination. Vibrational rotational analysis is also used for analyte discrimination, or NMR is, or radio waves is quite often used for NMR imaging. Your X-rays are used for CAT or mammography. Your visible spectroscopy is used in pathology, and microwaves are used for EPR imaging. So, nuclear transition is used for your SPECT and PET imaging. Your fluorescence used for analytical discrimination. Vibrational rotational spectra is used for your analyte discrimination, which has potential for in diagnostic. Hyperfine structure by using radio waves is used for NMR imaging. X-rays are used in mammography and CAT. Visible spectroscopy is used in pathology, and your microwaves are used for EPR imaging. Apart from medicine, spectroscopy is also used in environment. It is a very important technique for monitoring air quality. It is quite often used to test the water quality. So, for example, level of mercury or iron in water can be monitored using a spectroscopy. Similarly, level of CO2 or other toxic molecules in air can be monitored using a spectroscopy. You can analyze soil to address any environmental or health concern caused by different molecules, for example, pesticides or herbicides. So, this can be used to analyze and know the amount of these toxic compounds in the soil. This technique offers a green method of testing. So, this is quite a green method, and it gives you fast accurate results with the added benefit of saving money on the cost of consumables. Spectroscopy has been quite often used for forensic analysis. So, international drug enforcement agencies, police departments, custom laboratories rely on a spectroscopic technique. They can identify illegal drugs, crime scene evidence can be analyzed, banned material can be identified, and counterfeit goods can also be identified using spectroscopy. So, generally the seized drugs are basically controlled substances and cutting agents. They can be identified. Clandestine labs can also be identified. In the case of hit and run, paints and materials associated with the vehicle can be analyzed to catch a suspect. In the crime scene, identification of textile plays a very important part. So, you can look at fibers, coating and residues associated with textile, and that can help you in identifying a particular suspect. So, in forensic analysis, lot of time you have to analyze fraud documents. For example, even like fraud currency. Fraud currency has a different kind of ink or different kind of paper, but it looks quite same if you compare with the original currency. So, by identifying different type of ink and different type of paper, you can tell whether a document is a valid document or a fraud document. As I talked earlier, hair and fiber are important source in identifying a suspect. So, hair fiber chemical information can reveal residual hair styling products and protein structure changes due to chemical treatments such as bleaching. This additional information can prove to be very useful in identifying a suspect. A highly skilled forensic scientist can identify the physical characteristic that distinguish between generic fiber classes. However, further analysis including chemical analysis is needed to determine the chemical subclass. Trace analysis is also very important. Most important evidence at crime scene is your fingerprint, and fingerprint has different chemical component. For example, natural sebum oil from skin, which is basically a triglyceride ester, that can provide analysis of that can provide information about a particular suspect. Apart from these applications, spectroscopy also has applications in polymer and plastics. It can be used to quickly and definitively identify compounds such as compounded plastics, blends, fillers, paints, rubbers, coatings, resins and adhesive. It can be used for material identification and verification. It can also be used for copolymer and blend assessment. It can tell you what are the additives in those polymers and what is the amount of those additives in that polymer. It can also identify contaminants associated with that polymer, and these contaminants can be of different types, bulk or surface contaminants, and different kind of spectroscopy can be used to identify whether a particular contaminant is a bulk contaminant or a surface contaminant. All the molecules degrade with time. Some are very prone to degradation, and so spectroscopy is quite often used for molecular degradation assessment. So, spectroscopy has wide range of application. Spectroscopy has wide range of applications. So, apart from spectroscopy, we will be discussing microscopy. We will discuss the principles of microscopy, and I will go to principles of optical microscopy. I will also discuss principles of fluorescence microscopy, what are the different fluorophores and fluorescent proteins, and how to make use of them to study different phenomena associated with proteins. I will also discuss confocal microscopy, and I will be discussing FRAP and FRET. Then I will go to total internal fluorescence microscopy, and then we will discuss the application of all these microscopic techniques. I will also let you know how to record the image and if what kind of information we can get from the imaging, and how imaging can be applied to look at different processes at cellular level. Apart from optical spectroscopy, I will also be discussing electron microscopy. First, I will start with principle of electron microscopy. Then I will discuss advantage of electron microscopy over optical microscopy. So, what are the advantages of electron microscopy? I will also discuss scanning electron microscopy, popularly known as SEM technique. What is the principle of this microscopy and what kind of informations we can get from SEM. I will then go to transmission electron microscopy, popularly called TEM, and I will discuss principles of electron microscopy and how it can be used to know the different informations about the cell or about the proteins. Apart from optical microscopy and electron microscopy, I will also discuss scanning probe microscope. What is the principle of scanning tunneling microscope known as STM, and how it can be applied to study different processes. I will then go to atomic force microscopy, and as I have done for other microscopy, I will discuss principles and its applications. This is the way I will start. I will start with discussing dual behavior, and then I will talk about what is the properties of waves and particles. Then I will discuss about how the concept of quantization of energy came and what we mean by quantization of energy. Once we understand the dual behavior of waves and particles and quantization of energy, I will show you how to calculate energies of various quantized levels. and then finally, I will be discussing about selection rules for different kind of spectroscopy. I will also let you know what happens when electromagnetic radiation interacts with the matter, what happens when microwave radiation or IR radiation interacts with the molecule. So, I will go to each of the spectroscopy one by one, and then I will tell you about principles of this kind of spectroscopy and how to use it for different applications. Similarly, I will go to each of the microscopy and I will tell you about principle of that microscopy technique and then applications. So, after the course you will be able to know what kind of information we can get from a particular spectroscopy and how a particular spectroscopic technique can be used to look at molecules and how a particular spectroscopic technique can be utilized to study biomolecules and cells. The course will benefit a physical chemist, an organic or inorganic chemist. It will also benefit analytical chemist, biochemist, doctor and health professionals and industrial chemists. So, basically this course is useful for different kind of chemist and biologist. So, for example, if you take a physical chemist, what he wants to get? He wants to get physical parameters of a bond or a molecule. So, a physical chemist will know how to get bond dissociation energy or a dipole moment of a molecule using a spectroscopy. After the course, he will be able to know how to use spectroscopy to measure different thermodynamic parameters of a reaction, for example, enthalpy of a reaction, entropy of a reaction, free energy of a reaction. Similarly, he will be able to use a spectroscopy to measure kinetic parameters of a reaction, for example, activation energy, enthalpy of activation, entropy of activation. So, spectroscopy can be used to get kinetic parameters, and that is what a physical chemist is interested about. And physical chemist will also be able to know how to apply a spectroscopy to get information of dynamics or interaction of biological systems. So, spectroscopy can be used to study dynamics of a molecule or dynamics of a biomolecule and how two molecules interact. So, you can look at the mechanism, you can get the parameters like binding constant. This every parameters can be measured using a spectroscope. So, a physical chemist will utilize this course to understand physical chemistry of a reaction. Now, come to an organic chemist, how an organic chemist or inorganic chemist can gain from this course. They will be knowing how to use a spectroscopy to get the structure of a molecule or a product. So, if you think of a reaction, you need to know a product, what is the final product. You can use a spectroscopy to know the structure of the molecule, and that is what an organic chemist will come to know after doing this course. Now, organic chemist can also use a spectroscopy to know the mechanism of the reaction, and everybody is familiar how mechanism of reaction is useful For example, a substitution reaction which goes by SN1 mechanism requires different kind of conditions in comparison to a reaction which is going through a SN2 mechanism. So, for example, polar solvent will be useful if a reaction is going by SN1 mechanism, whereas it will not be that useful if a reaction is going by SN2 mechanism. I will also be telling you how to use a spectroscopy to know the impurities in the samples. So, an organic chemist can know what are the impurities in the sample by using a spectroscopy, and he will be able to apply a spectroscopy to differentiate between isomers of a molecule, isomers of the molecule. So, all of these aspects is important for our organic chemist, and organic chemist can use spectroscopy to further his research, his or her research. Similarly, this course will also be useful for a biochemist. He can use a spectroscopy to know the structure of protein or nucleic acid. He can use a spectroscopy to know the concentration of a particular biomolecule, and he can use a spectroscopy to know the km or kcat of an enzyme for particular substrate. Not only that, a biochemist can use a spectroscopy or microscopy to image a molecule or a biological process, and I will be discussing all of these applications in this course, So, I hope that biochemists will also be able to gain from this course. This course will also help an analytical chemist. He will be able to know how to use a spectroscopy to get the concentration of a particular analyte. He will be able to use a spectroscopy for trace metal analysis, and that is very important, particularly in environmental science and different kind of industries. He will be able to use a spectroscopy for analysis in forensic science, environmental science and food industry, and he will be able to use a spectroscopy for quality control in different industry. So, analytical chemist can also benefit from this course. Similarly, doctors and health professionals can also be able to use a spectroscopy to get help in their profession. They can use a spectroscopy for imaging the biomolecules, cells and tissues. After this course, doctors and health professionals will be able to know principle of different diagnostic techniques based on a spectroscopy and microscopy, and how to use it for different applications. For example, how to use a spectroscopy for tumor diagnostics and treatment monitoring. Similarly, they will be able to use a spectroscopy, or they will be able to know how to use a spectroscopy for knowing the concentration of molecules which may indicate symptoms of a particular disease. For example, they will be able to know the amount of glucose level, and by looking at glucose level, they will be able to tell whether a particular patient has diabetic or not. So, in summary, I will be discussing spectroscopy as discussed by a physical chemist, organic spectroscopy as discussed by an organic chemist, spectroscopy as utilized by a biochemist, spectroscopy as utilized by an industrial chemist or a biochemist, and imaging as applied by a health professionals and doctors. So, I welcome all of you to this course, and I am quite sure that you will be able to gain a lot from this course. Thank you, and looking forward for next lecture. Thank you very much.